Okay, now this is a video for the class in on last Wednesday. So remember in lab 9 we did some simulation already, but later on Doug Zada did some modification on the model. So this will be the final setup, and this video is for you to all the steps, and just in case you missed the class or you need to review all the steps. So compared to lab 9, we had some modification done, and this will be the final results. That will be a reference for you. Then let's go back to the same. Um, what Dr. Zada did on Wednesday was he removed those two constraints on the z direction, okay, where we still have this fully constrained, uh, this constraint here. So we removed that two constraint on the z and put another constraint here, okay, right on this point. If we turn on the star here, so this constraint is right on this the same node which uh, applied the force. Okay, so we change the constraint, then we change the value of the load of the force. So that will be 10 pound compared to 100 pound in lab 9. And the material property of this wood, uh, he changed that to the value of this Young's modulus to, let's see, 4000 psi. That'll be the number. So the wood, we change that to 4000 psi. Pay attention to the units. And the Poisson's ratio, you should uh, not need to change that, but it's 0.4 just in case. Okay. So constraint, load, material. Then what's next is in the same we added some a group. Okay, that would be the output group for the force in the C bush. So how you do that we'll show you in the video below. Uh, so anyway, with this group we will be able to output all the forces applied on the C bush, and so you can see them over here in F06 file. Okay, now you can see all the force on the pins, so that way you can remember the hand calculation. You have at each point you have x, y force, so you can compare your hand calculation with this force in bushing. Okay, so that's pretty much it. I believe he still demonstrated what will happen if we don't have the okay, if we don't have the constraint here. Why do we need this constraint on the z direction? And he put a bailout to -1 and forcefully run this simulation, so the pliers or the cutter will rotate on this wood. Then you got like 35-inch or 38-inch at this point at z direction, so the whole thing will go up or go down rotating. So that's just for demonstration. I will also show this in the video. So now let's start uh, doing these to recap the class on Wednesday. So first I'm gonna close everything here.